Well, hello everybody, and welcome to our February edition of the Akka.net Community Standup. This was supposed to happen last week, but with all the stuff we've got going on, I needed a little bit more time to get everything up and running. Gregorius, how are you doing today?
Oh, I'm fine. Thank you. How about you?
Busy as usual. We have done a whole bunch of releases. Mostly it's been kind of the big main flagship Akka.net releases that we've been putting a lot of time into. But we've also been working on a couple of other little side projects that we've been incorporating into some new projects that we will talk a bit about once we have shipped them. Not quite done yet. SDK bin is definitely one of the two that's getting a lot of attention and a lot of Akka.net use. But I've got kind of another front burner project right now that is almost across the finish line. We will talk more about that once it's actually available. So let's dive into talking a bit about our actual Akka.net releases. Akka.net 1.5.59 was a fairly beefy release. Let me go ahead and pull this up here. This was a fairly beefy release that touched a bunch of different little concerns. Let me scroll down here. So we basically fixed a pretty rare and unusual Akka.net clustering bug here. This was basically a case where a member who was not part of the cluster could be seen, and this would basically cause a serialization error inside the Akka.net cluster system. So we've added a small filter to that. I think some of the changes that we're going to be introducing in a future release of Akka.net will probably provide a more hardened fix here. This is an extremely rare issue, though, because I've basically only seen this issue get reported by one of our support customers this year. And the code that's in place here has been in use in production for like 7 or 8 years. So it seems pretty rare. Nevertheless, we did add a small guard here to kind of fix that. So that's taken care of. We fixed a couple of relatively innocent bugs inside like Akka persistence, core Akka, the test kit, etc. The big new things that we added, though, is that we've added the ability for Akka.net's logging system, the ILoggingAdapter, to effectively capture the activity context so you can correlate Akka.net logs to OpenTelemetry traces using the ILoggingAdapter. This is going to be especially useful for Phobos customers because this will eliminate the sort of data duplication issue that Phobos has when it comes to logs right now. That is a whole nother story unto itself, but long story short, this is basically how we are finally addressing that. And I'm using this in production currently. One of our applications works great. We'll get to that in a bit of a second here. The other thing we took care of is we kind of fixed some long-standing issues with a broadcast hub inside Akka streams, which is basically you can delay it from starting its broadcast until a certain number of consumers have attached to it. So this prevents a whole bunch of race conditions in our test suite, but it also makes it easy where if you basically want to be able to guarantee you've got at least 3 consumers before you begin distributing data, you can now enforce that using this parameter here. So that's one new thing we added. And the other little piece of telemetry that we included at the request of one of our customers, one of our support plan customers, was basically better logging around why we're exiting. And the reason why this is notable is this is our first time using semantic logging formally inside Akka.net's own internals now. So this should be able to capture why we're trying to shut down. Somewhat ironically, these logs might get lost because the process that is doing the logging might get terminated before it has a chance to flush this out to the system. We're gonna do our best anyway, but that's a somewhat of a limitation of trying to capture logs as things are shutting down. So that was our 1.5.59 release, which we did at the very end of January. And then the next release we did, which is a little bit more log specific, is Akka.net 1.56, which I'll go ahead and pull this up. We basically added a couple of long-standing and requested items to the ILoggingAdapter. This was essentially designed to make it easier for you to do Serilog style context enrichment and Microsoft.Extensions.Logging style scoping if you want to. The original use case where I kind of noted this was last year when we were overhauling AkkaStreams.Kafka. It would have been very useful for us to emit some sort of structured log indicating what topic and what partition we're assigned to. That's kind of the real basis for why this would have been useful. And the Scala sort of implementation of this idea was being able to simply just like prefix the log with like this little static message here. Well, this is one area where the .NET ecosystem probably has more mature options than the JVM one does, which is that we basically have, as a first-class citizen in our ecosystem, the notion of structured logging and also context enrichment. So I thought doing something a lot closer spiritually to what Serilog does is probably a better fit here than following what the JVM did originally. So this is what this looks like now. You have the ability to, when you create a logger, fluently call WithContext, where you define a variable name and a value. So for instance, we have a customer that was working on using this where they wanted to keep track of like a customer ID and then an operation ID right here. You can now very easily do that. Or if you have, let's say, a customer specific, sharded entity actor, you might want to enrich the context of the customer ID here and then create a temporary scope for a transient in-flight operation right here as well. So these are basically some of the pieces of functionality that we introduced in Akka.NET 1.560. This is all relies on using our new semantic logging formatter, which is enabled by default now. And this is probably where it's a good idea for us to pivot to talking about Akka.Hosting a little bit. Whoops, well, that's not the right URL. Let me go back here and pull that up from our list of pinned repositories. Oh, looks like GitHub went down. Or maybe that was an issue with my browser. Not totally sure. There's Akka.Hosting. All right. Akka.Hosting includes a pair of very interesting fixes. So the first is we made sure that WithContext and scopes is all properly supported inside Microsoft.Extensions.Logging. That's all been validated. I'm using this inside our own applications, so I can definitely attest to the fact that it does work. But here's the real moneymaker. We added the ability to correlate traces from the Microsoft.Extensions.Logging integration that Akka.Hosting introduces and the OpenTelemetry logger here. Now, there is a little bit of work involved in setting this up, which we have listed in the README for Akka.Hosting, and we also have it here on the pull request where this functionality was introduced. The thing you basically need to do in order to get this to work is in your logging pipeline where you configure OpenTelemetry, you need to call AddAkkaTraceCorrelation. This is going to basically produce a little log processor that is going to take a look at the Akka.NET logs and essentially correlate a trace to them if it exists. And this does work. We're using this in production on one of our brand new applications we're working on, and it works great. It allows me to basically turn off Phobos's append logs to trace setting, which we're going to try to retire soon. The only thing that's kind of really stopping us from retiring that on Phobos right now is actually the fact that our code signing certificate expired this week, and DigiCert has not quite gotten around to provisioning me a new one yet. We just completed validation on that yesterday, and so I should get that probably by Friday. But that's what's holding up our ability to do a Phobos release right now, is just rotating our certificate. Okay. So that is all done. A couple of other things I should note on the logging side of things is if you're a Serilog user, we have pretty significantly altered how that works inside Akka. Let me pull that up real quick. Let's see, Serilog. And if we take a look at the release notes for 1.560, grab this here. So long story short, the Serilog logging adapter is now obsolete. You do not need to use it anymore. And this is because all of these same types of context enrichment that the Serilog logging adapter allowed you to do with the for context method, this is all now natively supported out of the box on the default ILoggingAdapter. So you do not need to use this anymore. Now, the Serilog sync that'll write out to all of your configured Serilog stuff under the covers, that still works. If you have global enrichers set up, that still works. It's just that inside your actors, you do not need to use the Serilog logging adapter anymore. We've taken a lot of the functionality that component was kind of useful for, and we've just rolled it up into the built-in ILoggingAdapter now. So you don't need to use this anymore. These are now marked as obsolete. They will still continue to work, so you're not going to get a compilation error or runtime error or anything. But just know that we're retiring those since they are no longer necessary like how they once were. So that's another change worth noting there. Let's see a couple of other things that we've released. Fixed a pretty bad memory allocation issue with Phobos. I'd recommend upgrading to Phobos 2.10.5. The issue there was that we had a customer that was sending messages that got stashed, and those messages had when you called to string on them, they were like gigantic JSON payloads, like hundreds of hundreds of megabytes. We no longer stringify the actual event payload anymore inside Phobos's stash, so that should help be less spiky as far as allocations go. Also made one other minor fix on the MongoDB side of things. We kind of pushed that out. That was a request that a customer had, so we took care of that. And now that that's all done, I think we should talk a little bit about some of the upcoming Akka.NET releases. Here's some of what we are working on behind the scenes. So, well, actually, maybe before we move on, Gregorius, is there anything else that I should cover real quickly on the Akka.NET release before we talk about the future stuff?
No, I don't think so. I think you covered everything.
Well, I guess just 5 minutes before we started, we published an update to our MS Test cascading. We have an update
Oh,
to that
yeah.
every year.
Yeah, we do.
Yeah, that's
Uh,
so recently we didn't have a chance to add it to the agenda. So I
yeah,
guess
it's we added support for MS Test for .x now. So if you're targeting .NET 8 and above, you can actually use the MS Test 4.x version, which are unit testing.
yep. So that's available now as well. I think if you are in our Discord, you should have seen a notification about that hit the general room right before our meeting started.
Mm-hmm.
All right. So that leads me to talking a bit about what we're cooking up for Akka.NET in the future. So I have a triad of little projects that all exist in my personal repository. One is our Akka Reminders plugin, which continues to get a whole bunch of usage. I think I've got, I don't know, close to 5,000 installs of that so far. The Akka Reminders plugin, we did a little patch on to fix us a performance issue that one of our customers noticed in their production environment. So we did some stability fixes to Akka Reminders. That just went live the other day. But the two big ones I want to talk about today are our Aspire integration and our Akka.NET serialization proof of concept for 1.6. Let's talk about the Aspire integration first. So this is the repository here. It should have been the email and in the Discord message and in the YouTube description, but in case it's not in any of those, I will paste that into chat right now. All right, there we go. So this is where you can find this. It's available on NuGet right now as okay. Well, that's a problem. I guess I don't really have a prominent badge on here. Well, here we go. Here's the names of all of them. We got Aaron.Akka.Aspire, Aaron.Akka.Aspire.Hosting, and Aaron.Akka.Discovery.Redis. This repository contains, all three of these. We decided to go with a Redis-based discovery plugin for this approach because that seems to show up pretty frequently with Aspire anyway. So I figured, why not do that? The alternative was using the same approach that Gregorius originally pioneered, using Akka Discovery to Azure Table Storage. We figured Redis would probably be a little bit more universally applicable and kind of easier to build. This is basically what calling this plugin actually looks like. After you install the Aaron.Akka.Aspire.Hosting, you just go ahead and say, all right, I'm going to add a Redis instance, and then I'm going to add Akka, and then I'm going to say with clustering Redis, you go ahead and pass in the little Redis plugin here, and boom, that'll all go ahead and work. Inside your actual application, if you install the Aaron.Akka.Aspire package, this is like the client side package. If you install this into here, you just pass in your Redis configuration and call with Redis discovery, pass in this value, and it'll just work. You can also do things like pass in other cluster configuration values below here. Like in this case, I'm setting a role name, and that should work. This will also automatically register any of the health checks that are built into your Akka.NET application. Aspire will look for those before it starts up. We have some description here, the discovery bits. And I think I included an example of how to change the discovery engine around. If you don't use Redis, if you like using Azure Table Storage and want to do that, this will still work. You can go ahead and still pass that into the with clustering extension method that is exposed by the hosting plugin, and that will all work. I just this morning migrated drawtogether.net to go ahead and use the Akka.net Aspire plugin, and I figured I would demo that for you real quickly. So I go and I pull out Draw Together. Looks like I already have it up and running, but what we have done here is like a little configuration section. We turn Akka management off when we're doing our end-to-end integration testing. So instead of running a 3-node cluster, we run just a single node. That way it makes the integration testing process go through significantly faster. But when we run this just via a normal F5 from JetBrains Writer or the command line of Visual Studio, we usually run a 3-node cluster as part of this. So I went ahead and I added Redis. I configured clustering. I referenced, let's see, what's Akka? Oh, yeah, basically I just went ahead and had the application reference our clustering config, and then I added an explicit health check here, which didn't actually do anything, so I can probably get rid of that. But if I go to our Draw Together dashboard here, you can see that we've got a 3-node cluster formed. We've got Redis, and everything should, if I go and reload the screen here, should just work behind the scenes, no problem at all. Well, that's not the color I wanted, but that's okay. All right. And there we go. That's all working behind the scenes here using our 3-node Akka.net cluster. So this should, and if I take a look at the actual pull request itself and look at how much source code it was to integrate this, we were able to delete this entire file. No offense, Gregorius. This was beautiful work at back when we needed it, but now we've largely subsumed this into that plugin. Add a couple of plugins, and then inside the application itself, let me find it. Inside the application itself, we basically just checked a little Aspire configuration value and use this. Otherwise, we go ahead and we use the existing pathway that was there before. So that's the Aspire plugin. Works pretty well. I'm using it in another one of our production applications right now for local, actually 2 of our other applications for local testing and development. Works great. Highly recommend it. This will either get contributed to one of the Community Aspire plugin repositories, or we'll go ahead and merge it into core Akka.net as part of 1.6. Now, speaking of 1.6, I want to talk about a couple things before we get into serialization. Couple things we're looking at doing for Akka.net 1.6 is turning the core Akka.net repo into a bigger mono repository than it is right now. Things like Akka.Hosting, Akka management, and some of the logging and persistence plugins would all probably get rolled into that repo. Sure, that would make doing local builds and testing take longer, potentially, a lot longer, potentially. So we would need to overhaul our CI/CD process to accommodate some of that. That's something we already have to do anyway. And incrementalist, which we've talked about before, makes it fairly easy to separate workloads if we need to. So that's not the end of the world, but we're probably going to do that in order to make it easier for us to validate that changes to core Akka.net are safe with all these downstream plugins. So that's something we're going to do that should help make it so plugins get updated more regularly, and also makes it easier for us to do quality assurance on them. That's something that we're looking at doing. And then finally, we should talk a bit about one of our more ambitious goals for Akka.net 1.6, which is redoing the serialization system. Now, Gregorius, you were the one who originally prototyped SourceGen serialization. I took your idea and just dialed it up a bit.
That's cool.
Uh-oh, I accidentally unplugged my headset here. All right. Sorry about that. But yeah, I basically just took your original sort of work and dialed it up a bit. Andrew has submitted a pull request here that, with all due apologies, I have not reviewed yet. Since he's the message pack expert. But let's talk a little bit about structurally what we're trying to achieve with this project. We want to automate the process of creating schema-based serialization. Right now, the default serializer in Akka.NET 1.5, which is the same default serializer we've had since Akka.NET was originally built, is Newtonsoft.json, which uses an approach known as polymorphic serialization. This means that we take your C# and F# types and use them to represent the wire format as well. That's essentially what we're trying to do with polymorphic serialization. And that's useful insofar as it allows people to get up and running quickly and kind of automagically automates the process of serialization. But schema-based serialization has three major drawbacks. The first and probably most significant drawback is that it is very brittle. It's very easy to go and break your wire format. One person on your team with a resharper license deciding to do change namespaces can brick all of your old data sitting inside Akka.Persistence if you're using Newtonsoft.json. That's a pretty significant issue. The second issue is security. It's possible for untrusted types to basically get sneaked into your wire format, and those polymorphic serializers will attempt to instantiate them. Now, we have a pretty good naughty list of illegal types we will never allow the serializer to instantiate, which addresses probably the biggest surface area for that. But that's a problem with anything that uses reflection to do serialization, is that type of vulnerability. And then the other problem that polymorphic serialization has is that it is ridiculously slow. It's especially slow during deserialization. It's probably the most non-performant part of it. So there is a strategy that solves all three of these problems very eloquently, and that's schema-based serialization. This is where you define a separate format for your wire types than your actual application types. Historically, what we've recommended people do is define protobuf messages using .proto files, and then you write a serializer string manifest implementation to map that. And that process, while it's very easy to understand, as I note here, it is very, very tedious to do. Developers complain about this ad nauseum, and it's understandable. It is, if you have a lot of wire types, this takes quite a bit of time to arrange the first time. The other structural problems that Akka.NET serialization has generally, and this is independent of what your serialization format is that our APIs are very allocation heavy. We wrote the original serializer classes long before something like system.memory was in the picture. So we kind of have a bit of legacy baggage here that results in us having to allocate pretty heavily. The other problem that we have is that plugins like Akka.Remote, distributed data, Phobos, they all use what's called a composition strategy for being able to use an outer type that wraps an inner type. And this is how your wire format gets laid out. This is how, for instance, we can decorate a message with tracing inside Phobos, or how we can decorate a normal data type with a distributed data CRDT in distributed data. And then Akka.Remote decorates those messages with its own wire type. The way this works today, if I pulled up the Akka.NET source code, let me find in core Akka.NET the serialization helper real quick. This is a lot of backstory, and I apologize for that, but it's useful context. If I go to core, let's go to Akka.Remote serialization, and it'd be, I think it's the wrapped payload support. Yep, this little guy. This wrapped payload support class is what's used inside the remoting layer to basically figure out, oh, I have a nested internal serializable type. I'm going to turn that into this payload object, which will then get consumed inside my message container serializer right here. And the long and the short of it is every single one of these round trips produces allocations where we're basically deserializing a byte array, copying that byte array into another protobuf message, deserializing that, et cetera, et cetera. And you can get 3 or 4 layers deep potentially. This is a performance problem, especially for distributed data, where it actually affects our bit rate pretty noticeably as a result. So there's a path forward here where we can address these problems as well, make enveloping more simple. And let me talk you through what that looks like in the new version of the serializer that we're experimenting with now. The first thing we're going to require you to do as part of working with an Akka.NET serializer is something you should have been doing already, but if you're not, the type system's now going to force you to do it, which is all messages that belong to the same family need to be decorated with a common interface. When you've watched any of our tutorials or read through the new boot camp or anything like that, we naturally do this through things like the I with user ID or I with customer ID interfaces. This is what basically defines your protocol class. All messages that belong to that entity all implement this interface. Therefore, this is a reliable protocol definition here. Next, when you start creating records, this should look somewhat similar. If you've used like protobuf.net, this is very similar, where essentially what we're doing here is we declare every single type that can be serialized. We declare an Akka serializable attribute, and then we assign all of the fields an integer-based ID. This is very much spiritually similar to what users were already doing with protobuf. And then the manifest by here, this is basically how this type is identified on the wire. And these fields are used to identify what data is stored in the binary layout of this message. So as long as you observe two rules, don't change this, don't renumber these, you will have guaranteed backwards compatibility when you upgrade messages, provided that you do that. That's part of the goal here. Make extend-only design very easy for developers to achieve without forcing you to write these gargantuan classes. That's the first thing. Second thing you're going to do is you're going to create a public partial class, my whatever serializer, and this is going to inherit from the serializer v2 base class. And get a load of this. This generic constraint right here is going to identify all the types that this serializer is going to handle. We look for this interface, and then for every type that implements this interface, we look for these attributes. This is going to generate the layout that this serializer is going to use internally for handling everything. You can also do things like nested objects pretty easily through here. For dealing with a nested object, you don't need to declare a Akka serializable attribute. You just need to go ahead and declare these fields on the type instead. And Akka.net the Akka.net serializer will respect these and use them this way. So this is how you can do kind of like larger object graphs. Now, I won't bore you with the version tolerance stuff, which is basically just the rules that I mentioned. But here is in essence, let's see, does this actually get into the guts of how this works? Well, not quite. But basically, we're going to end up authoring all of this information for you inside the serializer. And this is going to be in a source-generated file. Couple of things that are a little different about serializer v2 versus serializer v1. So what's the bigger impact of this? Persistence or remoting? From a performance standpoint, absolutely it's remoting. From a version tolerance standpoint, persistence. So there's big impact on both sides of the axis here, but for different reasons. The primary objective of this is to eliminate toil, to make it very easy for you to essentially achieve extend-only design, which is the gold standard for doing like wire version formatting, and to make sure it's done very, very fast and efficiently. To help maybe seal the deal here, before I get into more of the details and how this works, let's take a look at actually the benchmark numbers. So we have three benchmarks here. Newtonsoft.json, basically v1 message pack. This is using the built-in message pack serializer. This is what Andrew is addressing in his pull request. He's got some better numbers for this than what I have here. And then the v2 message pack serializer implementation. So get a load of this. Flat message, a simple record with 4 fields. Newtonsoft.json allocates about 6K of data, takes about 60 microseconds, 59 microseconds to do it. Message pack v1 takes about 7 microseconds and does 248 bytes of allocation data. Our new v2 serializer only allocates 24 bytes. That's basically a struct allocation, is what that is here. We were able to use system.memory, and we're using what's called a codec writer strategy. This is like a stream buffer writer from system.memory. Now, our serializer, our write throughput is slightly lower because we are doing a bit of work that the message pack v1 serializer does not need to do natively. And there's a good reason for this that I'll get into in a moment. On the deserialized side of things, we allocate slightly more. I think this is basically this 24-bit overhead. Nah, this is a 40-bit overhead. This is probably an extra class allocation. So we allocate slightly more than the message pack v1 deserialized does. But as you'll see, once we start getting to like the much more complicated objects, the V2 serializer is going to start performing a lot better once we get to those, relatively speaking. But still, massive improvement over what Newtonsoft.json does. So as we get down here to things like enveloping, this is like what Akka.remote does today. Well, if I go ahead and do a serialization where it is, let's see, I think the V1 one layer serialized, this is just an Akka.remote envelope around a basic data type. We allocate a lot less data, and we are roughly a little bit behind, 0.02 microseconds slower than Message Pack V1. But get a load of what happens when we're dealing with like a distributed data payload, where you have 3 layers of enveloping happening. We take maybe a little bit longer, but we use a tiny fraction of the memory. This is because we do not need to allocate anything. We can fully take advantage of reusable buffers on writes inside the system. So the right side of the wire is very, very fast. On the deserialization side of things, we are going to be a little bit slower than Message Pack V1, but we're still allocating less. And then as we scroll down here and we start getting into, let's see, this is all serialization. This is the more complex types with nested value objects and all that stuff. Message Pack V1 out of the box is going to basically be a little bit slower on serializing the object graph here, and it'll eventually get a bit better as the performance will kind of come more into parity. Some of this might be honestly just like a little bit of jit overhead, but the performance starts to getting into parity a little bit more the more complicated the object gets. And then if I scroll down here on deserialization, we're roughly at parity. One big difference between how deserialization and serialization is going to work is that in Akka.remote and in Akka.persistence, we have a very short exit between when a message is serialized and when we're done using it. That means you can take advantage of buffer pooling there. With deserialization, the messages we deserialize might hang around in memory on the order of like months potentially, which means that we can't reliably use buffer pooling there because the object lifecycle is unbounded. Essentially, we would be reinventing garbage collection if we did that. So for deserialization, we are more or less going to just allocate bytes and return that. Let the garbage collector handle it. Don't try to do anything clever with byte buffer pooling. So that's something that we're not going to do. So generally speaking, we're getting pretty massive speed ups over. And here's the thing. We're not really comparing this to what we do today, which is the nested protobuf serialization. But Message Pack, basically using just the normal Message Pack performance, we're doing pretty much equivalent things. Now, the basic way this works, this sort of codec design, is we have a codec provider down here, which uses the Message Pack C# library. And this knows how to transform all these primitive data types into essentially their Message Pack compatible byte layouts. And the way this works and how we deal with things like nested objects is as we traverse through the different headers that are added by each layer of the envelope, we basically know how to parse those fields individually. And this allows us to go ahead and essentially linearly extract these nested messages rather than having to do several round trips of serialization this way. So I feel pretty good about this, that this strikes a good balance of performance and extend-only design and version tolerance. So this is kind of the direction that we are headed. I'm going to work with Andrew, who's our resident Message Pack expert here, on making this as performant as possible. So here's some of his data here. But that is basically kind of what we're working on right now. This should go hand in hand with the new Akka.remote transport, which will be able to take advantage of things like byte buffer pooling. So here's kind of what I'm expecting to see out of this. You should see a massive performance improvement in anything that has nested envelopes. That includes all Akka.remote messages, 100% of them, and especially situations like distributed data. You should see a big improvement on both write and read speeds on that. And then finally, we are expecting to see essentially very low amounts of like allocations on the right side of the channel. For deserialization, for those lifecycle reasons I mentioned, we still need to allocate as part of that. Unfortunately, there's not going to be like I said, any attempt to work around that essentially comes back to reinventing garbage collection. So we're not going to do that. But we are confident that we can make the process of extracting those messages coming off the wire radically faster than it is right now. So this should complement the work we're doing on the remoting pipeline pretty significantly. Let's see, another question from Jan here. Is there a plan to create a memory pack version considering we are in C#? Not at the moment, no. If there were a compelling argument to do that, we would. But I think basically just sticking with sort of just the message pack wire format and putting that out there, I think should be sufficient for our purposes. Where I'm really expecting the big performance improvements to come from with Akka.Remote, this will certainly help improving probably the biggest bottleneck right now in Akka.Remote is the fact that we process all messages in the channel linearly because it's TCP in essence. And deserialization is probably the biggest bottleneck there. The two areas where I'm really expecting big performance improvements are going to be from the fact that our quick-based transport supports, I'm totally blanking on the technical term, multiplexing. There we go. That's the term I was looking for. Supports multiplexing, which allows us to basically have multiple parallel channels for processing messages over the same connection. So that's useful. That basically avoids things like head-of-line blocking. The other is that we're going to have a compression scheme for being able to represent actors using integers rather than their actor path. And parsing the actor path and reconstructing it is also like one of the most expensive parts of Akka.Remote's networking system today. That in combination with making serialization faster, all of these should complement each other. So I'm expecting to see a pretty massive performance improvement in Akka.NET 1.6. So we're still experimenting with this and trying to get the vibe just right and get the technology right. And we probably got more iteration work to do on it still. But since we've been looking at it and working on it, I wanted to show you what our progress has been so far. I'm planning on starting work on this in earnest in Q2. So we're mid-February right now. So that'd probably be like mid-April, a couple months from now. That's my target date for making this my primary day-to-day thing. But for the time being, I'm still experimenting and trying to get happy with the various balls in the air that we have. Let's see. Gregorius, any questions or comments on this? Or if there's any questions from the audience, too.
It looks pretty cool. I mean, you haven't really shown me this yet, so this is all new for me.
I know. I'm sorry. I've been I've had my hands in a lot of pies right now, but yeah, no, this is available. It's all open source. I dropped all the links to these in Discord. If Jan, if you want to do a memory pack version of this and see if we can get a performance comparison there, I will totally merge that in. This is a dumping ground for ideas right now. This whole repository. I'm just kind of showing. Here is what I think is a good balance between performance, both in terms of memory and throughput, and type safety. I think this strikes a pretty, and also what's like intuitive and easy for a developer. I think this is a pretty good balance of all those concerns. I am very open to other suggestions here, though, since this is kind of we're still in the discovery phase of what would work well. So on that note, I think we've covered everything we want to cover today. Make sure you guys subscribe to the YouTube channel and stick around for next month's Community Stand-Up. Otherwise, we appreciate you. We appreciate your support of us and the Akka.NET project, and we will see you next time. Thank you very much.